Okay? Any questions? Okay. Maybe we can use the last few minutes to find the Fourier series expansion of a square wave. Say if I have a square wave. And it repeats itself. Okay, how do I find the Fourier series expansion of this square wave? Right? You all like squares, right? All engineers are square. You know what square means? No, okay, he doesn't know. So not all engineers know what square means.
Will be square.
Okay, so the coefficient would be given by 0 to t dt f of t e to the j n omega naught t. Okay, and then this would be 1 over t, right? I missed that. So then this should be 0 to d, okay, dt of 1, this is 1, e to the minus j, and omega naught is 2 pi over capital T times little t over there. Okay, you just need to integrate that. You integrate this, it's rather simple. Okay, so you get e to the minus j n 2 pi over t, and then divided by minus j n 2 pi over capital T. And then you have to evaluate this with 0 to d. Okay? So f of n then is equal to 1 over t 1 over minus j n 2 pi over capital T times e to the minus j n 2 pi over capital T times t minus 1. Okay, I think this is the thing, right? So your Fourier coefficient looks something like that. But how do I manipulate this into something more graceful looking?
It should be D, not T.
It should be D, yeah. You're correct, D. Okay, how do I manipulate that into a form that looks like something more graceful? What do you say again?
Bring the j to the top and cancel out the periods on the outside.
Okay. Okay, good suggestion. I want a better suggestion. How do you make this to look like a sine function? So it's a trick that you will use over and over again in engineering. Okay, 2 exponential function minus 1 doesn't look graceful enough to most engineers. So engineers like to convert this into something that looks like a sine function. So you use this trick, e to the minus jx minus 1. How would you make it look like a sine function? You take out half of it and leave behind half of it. And then because you took out half of it, the second term will have positive half of it left. Okay, this trick you do over and over again as an engineer. So when you combine these two, what do you get? You get 2j. Is it 2j or minus 2j? E to the j x over 2. And how does it express itself in terms of a sine function?
2j sine
minus 2j, right? Minus 2j sine of x over 2. Am I right? Because sine of x is equal to e to the j x minus e to the minus j x over 2j. Right? Yeah, I think I'm correct about that. So sine of x is equal to that. If I apply this identity, that should be minus 2j, somewhere right there. Okay? So if I apply this garbage collecting identity to collect all the garbage into one something that looks graceful, then f sub n is equal to 1 over t, 1 over minus j n 2 pi over capital T. And then using this identity, I will have e to the minus j x's. So I get n pi b over capital T over there. And then I get minus 2j sine of x, which is n pi d over capital T. So I have something that is expressible in terms of a sine function. Okay? I have terms that cancel each other. And then this cancels with that. And then what else do I have? I have something that looks like 1 over 2 pi n e to the minus j n pi capital D over t. There's 2 canceling with this 2, so that 2 goes away. Sine of n pi d over t. Okay, so f sub n looks something like that. Okay? So f sub n is equal to 1 over pi n e to the minus j n pi d over t sine of n pi d over t, right? Okay? So, have you heard of a function called a sinc function? Sinc of x is equal to sine x over x. Have you heard of this function before?
Yes.
Okay, engineers love this function. Okay, so we try to write this solution in terms of this sinc function. In order to do that, so I have n and pi. I have to put a d here. I have to put a d on the numerator. And then I have to put a t below. And then in order to do that, I have to put 1 over t above. So this can be written as fn is equal to d over t e to the minus j n pi d over t, the sinc function, n pi d over t. Okay? How does a sinc function look like? What is its value at x is equal to 0? It's 0 over 0, right? But you use what is called a L'Hopital's rule. Or it's a French rule. It's L'Hospital rule. Or L'Hopital's rule. Okay? So in French you call it L'Hopital. Okay? So it's equal to 1. Okay? So if you were to plot the sinc function, it looks something like this. Sinc of x. Okay? So the Fourier coefficients of a square function is a sinc function. Okay, it's a sinc function. So remember that the Fourier coefficient of a square function is represented by a sinc function. The sinc function looks very smooth. The square function is not smooth. So the sinc function was making joke of the square function and say, you are very square. But actually they are the same thing. Okay, pot calling kettle black. Because they're both square actually. Because one is actually a Fourier representation of a square function.
Such a bad joke.
So you got the joke.
I got it, which is such a bad joke.
So, I will be here next week. There will be a substitute lecturer coming in. Dr. Mokaba of Lapu will come in to lecture after travel. So,
We're not going to learn anything in class.
just remember the signals.
This guy did.